Okay, so now on to example number 3, where what we're going to do is learn how to find all of the zeros and then write the polynomial as a linear factorization. So again, just like in our previous video where we were finding all the zeros, we're going to follow the same process. We're going to look into using synthetic division or long division, and then once we've applied that once, to find all the zeros, we're going to either look into factoring, applying synthetic division, again, or also look into the quadratic formula. And I have a couple examples here, different zeros here. We can have, real rational, and then obviously since we're talking about irrational zeros in this section, we're gonna investigate what to do when you have irrational zeros, and then also one where you're given like two zeros, and how we can find all the zeros and then write it as a linear factorization. So in this first example here, you can see that we have a 0, x equals 2. And basically when we're given a 0, usually the most easiest thing to do is kind of work into using synthetic division. One thing I do notice here is I'm missing a x squared term. So remember, oops, let's go ahead and, why is that so? Remember when we're looking into using synthetic division, we got to make sure all the terms are covered. So in this case, since I don't have an x squared, I'm going to put a 0x squared, because remember, for synthetic division we got to use all of the coefficients. Okay, so what we'll do here is I will take the 0 on the outside, and then I'll create my nice little synthetic division section, and then I'm going to take the coefficients. Remember, that is going to be a 1 in front of there, so I'll have a 1, a 0, -2, and -4. So remember, just synthetic division, that first term you're going to bring down, and then you multiply the 1 times 2, which gives you 2. You add 0 plus 2 is going to give you 2. Multiply 2 times 2, which equals 4. Add these rows and you get positive 2. And then multiply 2 times 2, which then equals 4. And again, for all these problems, it's really important to understand that we need to get a remainder of 0. Obviously, if we don't get a remainder of 0, we got to check our work, because the problems are saying we have a factor. That means that factor is evenly divisible into the polynomial. Or we have a 0. That means, again, that 0 can be, divisible, or the factor of the 0 can be divisible into the polynomial. So we got to make sure we check our work. Now again, once we get this is the other factor, right, of the polynomial. So remember, this is your remainder, which is 0. This is your constant. This is the coefficient of your linear, and this is the coefficient of our quadratic. Let's go back in here. So therefore, we could set this equal to 0 here, because again, basically, if this is your 0, remember, then my factor is going to be x minus 2, right, set equal to 0. So therefore, if x minus 2 is a factor, that means this is also a factor, and to find all the remaining zeros, you just need to set all your factors equal to 0. So I'm going to set this factor equal to 0, and to see what I can do to solve it. Well, initially, I always want to look into factoring, but the problem is this is non-factorable. There are not two numbers that multiply to give you 2 that add to give you 2. So now, to go ahead and solve this, I'm going to need to use the quadratic formula. So again, if you have a quadratic set equal to 0, to find the zeros using the quadratic formula, you have x equals, and now we're going to take opposite of b, which will be -2, plus or minus the square root of b squared, so 2, minus 4 times a, which in this case is 1, times c, which in this case is 2, and then all divided by 2 times a, which is 1. Okay, now let's go and simplify this again. So we have -2 plus or minus. Let's see if we can do this radicand here. 2 squared is 4. -4 times 2 is going to be a -8. So 4 minus 8 is going to be a -4, all divided by 2. Now again, remember, we can break up a square root of a negative number into the square root of -1 times the square root of 4. So therefore, that's going to give us a 0 of -2 plus or minus 2i all over 2. And again, let me see, let's just do that on the side. I always kind of feel comfortable with that, because I know there's probably some students like, how did that happen? So remember, square root of -4 can be broken down into -1 times 4. Square root of -1 is I, square root of 4 is 2. So then I just wrote it as 2i. Go back to blank. All right, now, one last thing though, we can rewrite this. We can divide this 2 into both of those terms. So 2 divided by -2 is going to be a -1, plus or minus 2i divided by 2 is just going to be I. All right, so those are going to be my two zeros. So again, this is, x equals basically all the way to here. So if I wanted to kind of write my zeros here, I'll just kind of put it over here. So my zeros are going to be x equals 2 and x equals -1 plus or minus I. And I could write that in set notation, but in this case, I'm just going to write it like this. If I want to write this as a linear factorization, then what I need to do is write all my zeros as factors. Okay, and I'm going to set it equal to y, so it'll be y equals, again, my 0 x equals 2 as a factor is going to be x minus 2. Now this gets a little bit interesting as far as how I can write these as 0. So again, remember, these are, let's put this down right here, x equals -1 plus I, and x equals -1 minus I, right? So if I wanted to set these equal to 0, I need to add the 1 and then subtract the I. So like add 1, so it'd be x plus 1 equals I, and then subtract the I. So I'd have x plus 1 minus I equals 0. So now that is my factor. And you do the same thing over here. You can see the only difference is you'd have to add the I. So my final linear factorization here is going to be x plus 1 minus I times x plus 1 plus I. Okay, and now that's a product of my linear factors. You notice that I have two of my zeros are complex, and I have one real zero. If I go back to looking at the degree of my polynomial, you see it's 3. So therefore, I do satisfy the fundamental theorem of algebra. All right, let's change colors so I don't mix everything up. Now we're given a factor. So now kind of in the same thing though, it is a linear factor, and preferably when I have a linear factor, I'm going to want to use synthetic division. All I need to do is written my factor is set it equal to 0 to find the 0. So if that's the factor, that means x equals -2 is going to be my 0. So that's what I'm going to use for synthetic division. I notice that my polynomial is in descending form. Okay, that's a 1, so therefore I have all the coefficients, and I have a lot of 1s as coefficients. So let's go and set up the synthetic division. So I put in -2. All right, and then I have 1, 1, -1, 1, and then -2. Okay, so bring down the 1. 1 times -2 is -2. 1 plus -2 is -1. -1 times -2 is a +2. -1 plus 2 is 1. 1 times -2 is -2. 1 plus -2 is a -1. -1 times -2 is a +2. And again, we're good because we have a remainder of 0. So I have my remainder, constant, linear, quadratic, and cubic. So now I have a cubic, so now I can't use the quadratic formula, right? So the problem is I got to see, well, hopefully this is factorable because, otherwise I'd need to find another 0 that I could do synthetic division again with, which could, pose a problem here because we're only given 1 0 in this case. So let's go ahead and write this, x cubed minus x squared plus x minus 1. Okay, so x plus 2 is a factor. This is a factor, so to find the zeros, I'm just going to set my factor equal to 0, now solve. Now, again, I got to see, is this factorable? Well, since I have 4 terms, I know that I want to look into seeing if I can factor by grouping. So I'm going to group the first 2 terms, and then group the last 2 terms, and see, can I factor out common factors to get the same binomial? And in this case, you can see that in the first terms, I can factor out an x squared, and that will leave me with an x minus 1. And then here, I don't need to factor really anything out, but I do need to kind of represent factoring out a 1, so therefore I only have the x minus 1 as a product, so therefore or as an expression. So if I factor out a positive 1 here, you can see I'm left with x minus 1. Now that these are common, I have, let's see, x squared. Oh, let's factor out the x minus 1, that makes more sense. So I factor out an x minus 1, and therefore I'm left with a x squared plus 1. Okay, now again, remember, don't forget this factor up here, x plus 2, because that's still going to be part of our, that's one of our zeros. But if I wanted to continue solving this, I could use the zero product property, or I could just factor using difference of 2 squares across complex numbers. But let's just use the zero product property just to kind of remember here. Set them both equal to 0, x squared plus 1 equals 0. So therefore, x equals 1, and then again here, you're going to have x squared equals -1, and then you just take the square root of both sides. Now that I'm taking the square root, remember you have to introduce the plus or minus. Square root of negative 1 is I. Okay? So, my zeros, I'm going to use set notation here. My zeros are negative 2, which was given to us, positive 1, which we found here, and then plus or minus I. Okay? My linear factorization, I'm just going to use LF here to represent that, is going to be my product of my two factors, my two real zeros, or real factors that give me my real zeros, which would be x minus 1 and x plus 2. Okay? Right? X plus 2 and then x minus 1. Now, we can't use x squared plus 1 because that's not linear, that's quadratic. So again, all you need to do here is if you factor this across your complex zeros here, let's see here, I'll do that. All right. So now, basically, you can just factor this across your difference of two squares, which would be x minus I times x plus I. Okay? Which is basically the same thing here. You're setting these equal to 0 and solving, kind of like what I did over here, just a little bit easier. So, oops, sorry about that. But so therefore, not really, showing the step by step. But you can see here now that's written as my linear factors. You can see I have 4 zeros. 2 of them are real, 2 of them are complex, and my original polynomial is power to the 4, so it satisfies. All right, so now let's go and look into this. Now we have a 0, and you can see it's a complex 0. Now, one quick thing we got to understand about, if we're given I, positive I, then we know that the complex conjugate must exist. So therefore, I already have another 0, square root of 2. So x minus square root of 2 is another 0. Now, what can we do with those two zeros? Well, you could do synthetic division twice. Now that you have two zeros, you can do synthetic division over. But what I've found through my experience doing synthetic division with complex numbers or irrational numbers or even with fractions usually makes most students prone to making some sort of arithmetic mistake. So what I prefer to do is understand, well, if these are your zeros, right, if that's a 0, then all I got to do is add I squared of 2 to the other side. Wait a minute, what am I doing? X minus I, that's also a 0. What am I doing? That's x minus, I see, I wrote that wrong. Oops, no wonder, I was like, that's kind of confusing. Yeah, so x equals, no wonder, I was like, that doesn't make sense. There you go, I wrote that wrong, sorry about that. It's not x minus I is a 0, it's x equals I is a 0. So therefore, that means x equals negative I square root of 2 is also 0. So what's important about this is now I can write these as factors. Okay? And if I write them as factors, then they're going to be x minus I square root of 2 times x plus I square root of 2. And now that I have these as a product of two factors, I can multiply them. And fortunately, what you see is, again, what's as nice about dealing with complex numbers and their complex conjugates, you can see this is, again, the difference of two squares. So rather than going through the whole FOIL process, all I simply need to do is multiply them, right? Multiply them and just multiply the first terms and the last term. So when I'm doing that, I get x squared, and this becomes a, let's see, I times I, so that's going to be positive 1, so plus 2. So by multiplying these two factors, I am producing another factor of this polynomial. Now the problem with this new factor is it's quadratic, so I can't use synthetic division. However, I can use long division, okay? And it's kind of similar, like 2 and 3 are both factors of 12. You multiply 2 and 3, you get 6, and 6 is also a factor of 12. So that's basically what we're doing. We're multiplying our two complex conjugates to get another factor over real numbers that now we can use for using with long division. So let's go ahead and set up here our long division. So I have x to the 4th minus x cubed plus 4x squared minus 2x plus 4. All right, so let's see here. X squared is going to go into x to the 4th. X squared times x squared is x to the 4th. X squared times 2 is going to be a positive 2x squared. Subtract my rows. Therefore, now I bring down negative x cubed. 4x squared minus 2x squared is a positive 2x squared. I'm just going to bring all of these down, subtract them from 0. Okay, now we follow the same process again. X squared goes into negative 3x, negative x times. X times x squared is going to, negative x times x squared, I'm sorry, is negative x cubed. Negative x times 2 is a negative 2x. Subtract my rows. Subtract these down. Those all go to 0, so I'm left with 2x plus 4. X squared divides into 2x squared, positive 2 times. 2 times x squared is 2x squared. 2 times 2 is positive 4, and you can see these are exactly the same, so when I subtract them, obviously I'm getting 0 as my remainder. So, right now we have x equals I squared of 2 is a 0, x equals negative I squared of 2 is a 0. And then I have this as my other factor, so let's set my other factor equal to 0. And you can see it's a quadratic trinomial, so we want to factor it, and if it's non-factorable, then we're going to have to use quadratic formula. But fortunately, you can see, wait a minute, x squared goes in 2x, and I messed that up. That's supposed to be a negative, positive 2x. That's not factorable. So I messed that up. That's supposed to be a 2x, bring down the 2x. So therefore, that means that was supposed to be, I gotta change this problem. Alright, let's see what I have here. So I need this to be a negative 4x, so maybe I forgot to change that. So this becomes a negative 4x. Sorry about that. I had to change these problems. So that becomes a negative 2x. I had to change these problems, so if obviously you're reviewing this afterwards, you've already seen that I've changed these. So that becomes negative 2x, bring down the negative 2x. So x squared goes into a negative 2x, negative 2 times. Yeah, you want that. Negative 2 times. Negative 2 times x squared is a negative 2x squared. Negative 2 times 2, it becomes a negative 4. So those are supposed to be negative and negative. That means that last one is supposed to be a negative as well. Sorry about that. I worked through this twice, and I made that mistake twice. How embarrassing is that? But whatever. It happens. All right, so therefore, then again, you're going to get 0. And so the whole point of this was, obviously, I wanted something that was going to be factorable, not something that was going to be quadratic formula, because it's just going to, I already did an example on quadratic formula, so I didn't want to, keep on doing quadratic formula problems. But anyways, so you go ahead and work this one. You can see this is now factorable into x minus 2 times x minus 1. Okay? So if we're going to write these zeros, so now we can say these zeros here, is I can just write these up here as plus or minus I squared of 2. And then we have these are two real zeros, which is 2 and 1. Okay? The nice thing about writing the factors over here, if I want to write the linear factorization, y equals, I can just write these two factors, I squared of 2 times I plus, hence x plus square root of 2, x plus I square root of 2, and then I have these two factors over here, minus 2 and x minus 1. Okay, now we got another one. So now we got another irrational 0, and again, the conjugate is going to exist, so x equals 2 plus I. And again, we're going to want to kind of do the same thing. I'm going to write them as our factors. So if we want to write them as factors, we need to subtract the 2, add the I. Subtract the 2, subtract the I. So therefore, I'm just going to write the factors over here. Actually, you know what? Let's do this in green. Okay, so x equals 2 plus I. So therefore, we can say the factors. So the factors now I have is x minus 2 plus I, and then x minus 2 minus I. Okay? Now again, this one isn't as fun to be able to multiply this out, but if you remember my shortcut, what we can do is put some extra parentheses around here, around the x minus 2's. And this was the shortcut I did for the irrational zeros. So therefore now I can multiply this via difference of two squares. So therefore it's going to be x minus 2 squared, and then I times a negative I, which would be a let's see, it's going to be a negative I squared, which is negative 1, so negative 1, which is positive 1. So therefore that gives me x squared minus 4x plus 4, and then plus 1. So therefore that's going to be plus 5. So that's what I'm going to use for my synthetic division. Otherwise, you could do this for using synthetic division, but I think it's just a little bit too much work for me. So let's go ahead and use this for our synthetic, or for our long division. I'm sorry. Okay, and then I'm just going to take x cubed minus 2x squared minus 3x plus 10. Okay, x squared goes into x cubed, x times x squared is x squared. X, now again, you have to multiply the x times every term. X times negative 4 is negative 4x, I'm sorry, is a negative 4x squared. And then x times 5 is going to be a positive 5x. Subtract at rows. Remember, you're subtracting every term. So x cubed times, that's a cubed. X cubed minus x cubed is 0. Negative 2x minus a negative, so that's really positive, is going to be a 2x squared. Negative 3 minus 5x is going to be a negative 8x. And then 10 minus 0, you can just bring down the 10, positive 10. All right, so x squared goes into 2x squared, positive 2 times. 2 times x squared is going to be, 2 times x squared is a 2x squared. 2 times negative 4 is going to be a negative 8x. And 2 times 5 is positive 10. So, not too bad. The difficulty with this one, obviously, is multiplying this, and obviously you could use the box method or whatever else, but obviously the more and more practice you get with this, you can see kind of the quicker you're going to get. So my zeros are just going to be x equals, I'm going to write this as plus or minus 2 plus or minus I, and x equals, again this is a factor, so therefore the 0 would be negative 2. Now my linear factorization would be y equals, and we can just write these here as our factors. So I can write x, sorry, let's get that up. So x minus 2 plus I times x minus 2 minus I, and then times x plus 2. All right, so 2 more, guys. We're almost done, but you guys, hopefully you can kind of see a little bit of the pattern that we're kind of developing with this. One last one here, I have negative I. So again, let's do dark green. So therefore the other 0 is x equals I, right? We can write these now as our factors. Write them as your factors. Hopefully you're seeing that this is going to be a x plus I times x minus I. And when we multiply that, we get x squared plus 1. Okay? So again, we don't want to use, again, you can use long division. And I used to teach it doing long division, I'm sorry, synthetic division all the time. I just found that my students and myself made mistakes. But this one wouldn't be too bad to use long division, or synthetic division again twice. But I still think as long as you have that long division, I mean, you've seen that it really hasn't taken that much extra time for us doing long division. And again, when you do synthetic division, you have to use twice. You have to use both zeros. So you have to do synthetic division twice. So I don't really think there's an advantage in using synthetic division for a lot of these problems. All right, so let's go and divide this, see what we get. X squared divides into x to the 4th. X squared times x squared times x squared is x to the 4th. X squared times 1 is going to be an x squared. Subtract. We're left with an x cubed, and then 5x minus this is going to be a positive 5x squared. Let's just subtract all of them, so let's bring it all down. Okay, now x squared goes into x cubed. X times x squared is x cubed. X times 1 is a positive x. Again, subtract the rows. 5x squared, bring that down. Okay, so x squared goes into 5x squared plus 5 times. 5 times 5x squared is 5 times x squared, sorry, is 5x squared. And then 5 times 1 is positive 5. And then subtract. Okay. And you can see the remainder 0. So again, you can see here we have this lovely 0, but unfortunately, guys, that's going to be another quadratic formula. So that's all right. I mean, hopefully you can see we're doing a lot of these problems because I want you to be very, very confident in using the quadratic formula. So let's solve this. So 0 equals x squared plus x plus 5. All right? And that's why you can see why I knew there was that mistake in the other one, because I'm like, I know I only chose 2 quadratic formula ones. So to solve for this, it's x equals opposite of b, which is 1, plus or minus square root of 1 squared minus 4 times a times c. And then all over 2 times 1. Okay, so we have 1 plus or minus. Let's see, that's going to be 1 minus 20, so that's going to be square root of negative 19 all over 2. And then we can just simplify this into 1/2 plus or minus 1/2 I square root of 19. Okay, so basically what I did here is, oh, maybe I'll show it down below. I got a little bit of room, right? So if I was to break this up, remember we can square root the negative 19 into I, right? So it's 1 plus or minus I square root of 19, because the square root of negative 1 is I, divided by 2. And then basically I just divided the 2 into both of those. So it would be 1 over 2, plus or minus I square root of 19 over 2. And instead of writing it as dividing by 2, I just rewrote it as 1/2. So either one of these are acceptable. Usually you'll see as like a multiple choice, you'll see it written in this format, but there's nothing wrong with writing in that format either. All right, so we have our zeros, I and negative I. And then you can see here, we also have 2 more complex zeros, right? So this example actually has all complex zeros, which makes sense. First of all, there's 4 complex zeros, so that follows the fundamental theorem of algebra. There's no real zeros, and this is an interesting one, which we'll come back into later why there's no real zeros. But it's possible, and again, if you think about this, this is an even function, so it doesn't have to cross the x-axis. So that's what kind of makes this one special. So our zeros in this case are going to be plus or minus I, comma, 1/2 plus or minus 1/2 I, oops, plus or minus 1/2, yeah, plus or minus I squared 19. All right, my linear factorization. I did not give myself enough room for linear factorization. But either way, let's do it. So y equals, so my linear factorization would be x plus I times x minus I times x minus 1/2 minus 1/2 I. Wait, what did I do? Yeah, 1/2 I square root of 19 times x minus 1/2 plus 1/2 I square root of 19. Not very, very fun zeros, right? Not very nice to write out. But that's it. So, all right, let's go ahead and group this out. So I'll try not to do my work impeding that. So let's use red so we're not going to be confusing. All right, now I like this problem a lot because you can see here, now we're given 2 zeros. And when you're given 2 zeros, that's kind of like a gift a little bit. They're basically telling you, hey, you have 2 zeros, you're going to want to use these. It's kind of like when we get the complex conjugates. Like, hey, if you're given a complex number, you can use the other 0. And that can be helpful in synthetic division. So immediately when I look at this, I say, all right, I'm going to use synthetic division. So I'm going to, first let's divide with 2. I like 2. All these in order? Yes. So I'll take 2. And let's do synthetic division. So I have a 1, a 2, -5, 6, and a -24. Okay, so by applying synthetic division here, I bring down the 1. 1 times 2 is 2. 2 plus 2 is 4. 4 times 2 is 8. -5 plus 8 is 3. 3 times 2 is 6. 6 plus 6 is 12. 12 times 2 is 24. Okay, now it's very important that if you're going to continue dividing, all right, when we do synthetic division again, we don't want to do it to the same polynomial. That's like saying, what are all the factors of 12? And let's say, well, let's divide by 4, and then let's divide by 3. That's not helping us like find all the linear factors. What we want to do is, once you divide by 3 and you get a factor of 4, we want to continually factor down 4, which would be 2 and 2. So I can write this. I mean, this is, this is another factor. So let's see, remainder constants. linear quadratic. So this is x cubed, plus 4x squared plus 3x plus 12. And you can actually see that this is actually factorable by grouping. You can actually factor that by grouping. But I'm just going to go under a method that it's non-factorable. So how can we kind of show this, what the other zeros would be? And actually, I'll show the grouping technique. But let's use -4. If I go ahead and use -4 now I'm going to use synthetic division again, but with these factors. And sometimes, especially even if you're not good with factoring by grouping, just follow this process. -6, 6, and -24. So bring down the 1. 1 times -4 is -4. 2 plus -4 is -2. -2 times -4 is +8. -3. -12. -6. And 24. 0. So again, in this case we have, I just did the exact example that I told you not to do. This is what happens when you're not paying attention. Okay, you got to take these coefficients, not these. That would be just dividing 3 and 12 and 4 by, or 12 by 4 and 12 by 3. You got to take these coefficients. So 1, 4, 3, and 12. Okay, last video, I guess. I'm just tired. So bring down the 1. 1 times -4 is -4. 4 plus -4 is 0. 0 times -4 is 0. 3 plus 0 is 3. 3 times -4 is -12. Okay, so you can see a remainder, constant, linear, quadratic, which basically gives us 2x squared plus 3. So that's my other factor. Now, can I solve for that factor for the zeros? Yeah, of course. You could subtract the 3 and take the square root, or hopefully, maybe at this point, you see that, oh, I can factor these across complex numbers. So minus I squared root of 3, and then x. Let's move that over again. So the x plus I squared root of 3. All right? And now, those are my 2 zeros plus my other 2 zeros I'm given, which is 4. Now, just real quick, if you would have seen that factoring technique, or if you would have seen grouping and you just wanted to stop and go for grouping from there, awesome. Let's make sure we get the same answer. So here, I could factor out a x squared out of the first 2 terms. By doing that, I'm left with an x plus 4. And then here, I can factor out a 3. X plus 4. Factor out the x plus 4. So now I'm left with x plus 4 times x squared plus 3, which again is going to give us exactly what we were looking for. So now let's just go ahead and list out the zeros here. So either technique really would work. We're given our 2 zeros, so that's going to be what? 2 and -4. So we can say 2, -4. And then I'll just say plus or minus I squared root of 3. Then if I wanted to write the linear factorization, I would say y equals, let's see, x minus 2, x plus 4, and then x minus I squared root of 3, and x plus I squared root of 3. So there you go, ladies and gentlemen. That is how you find all of the zeros of a polynomial, especially when given complex zeros, or to continue finding complex zeros when you're given a zero of a factor. So I hope that was helpful for you. You guys can see some examples of synthetic division, see some examples of long division. Just remember, always try to factor something, and if it's non-factorable, don't change the answer. But I know I made a mistake, so I apologize for that. But or don't change the problem to avoid doing the quadratic formula. But yeah, just go through the quadratic formula. Look for factoring though. I think that will really make your life easier when you recognize factoring. And sometimes if you're given more than 1 zero, you can do synthetic division more than 1. So that is really the kind of main last process we're going to have for this. And now we're going to bring into some theorems that's going to kind of make sense of it. So that will be coming up next.